Now that it's created a project for me, the next step is to read in the structure of an existing database. Under the Objects menu, choose Add Database, and select your database connection information. If you're using an ODBC DSN, you can simply choose it from the drop-down list. If you'd rather type a connection string, you can do that instead. If you want to use an OLE DB provider, you can either type the connection string or click on the Build button to bring up a dialog where you can visually build that connection information. If you're using Visual Fox Pro Data, you can specify a database container, a free table directory, or if you're using something like the Stonefield Database Toolkit or Visual Fox Express, you can point at some DBCX metadata. Finally, you can choose an empty database, which means that it will create a database with no tables in it so that you can manually set those up. This is used if you want to query against non-traditional data sources, such as flat text files, web services, or other things where Stonefield Query cannot go and read the structure of the database. For this example, I'm going to use an ODBC DSN that points to the Northwind sample database that comes with SQL Server. There are other options in here as well. For example, by default, all tables will be added to the data dictionary. If you don't want that, turn this option off, and you can then choose from a dialog which tables you want included. By default, no views are pulled in, but if you turn this option on, they will be included as well. Now that I have my options set, I'm going to choose OK. And what the configuration utility is doing now is reading in the Northwind SQL Server database structure. It's pulling in all the tables, fields, relationships between tables, descriptive names for tables and fields, and so on. Now, one of the things that I found along the way was that there's actually a self-join in the employees table. I won't go into detail about how this works, but essentially Stonefield Query wants to create a subtable of the employees table that will contain manager information, and it wants to know what I want to call that. So I'll call it managers. Alright, so now here is the Northwind database that Stonefield Query has read in. Here are the tables that are in that database. If we drill down a little bit, we can see these are the fields in the customers table. It knows, for example, that the company name field is a 40-character varchar with a descriptive name of company name. It also read in relationships, so it knows, for example, that the customers table joins with the orders table by matching on the customer ID field in each table. The next step is customizing the data dictionary. And there are several things you might want to do here. If Stonefield Query didn't read in any descriptive names or relationships, you might take the time to do that now by putting in, for example, a descriptive caption for each field or defining your relationships here in the data dictionary. Other kinds of things you can do are, for example, to make certain tables non-reportable. Some of these tables are here for reporting purposes. I don't want the user to be able to query on them, so I just simply turn off reportable. And you can see by the red X in the list that these tables won't show up in Stonefield Query. You can do the same thing at the field level. For example, in my customers table, the customer ID field is a primary key. If the user never sees that in their application, they probably don't want to see it in Stonefield Query either. So we can make that field non-reportable as well. Now, this is an all or nothing thing. Either all users can see these tables and fields or no users can. We also support role-based security at the data dictionary level, and I'll get into that in another webinar. We can also do things such as creating calculated fields. For example, the order details table is a normalized table. We have unit price and quantity fields. We don't have a total price field. Of course, the user will certainly want to query on that, so we'll go and create one now in the data dictionary. Under the Objects menu, I'll choose Create Field. Now note that this is not a create a field in your table. This is something that's stored in the data dictionary only. We'll call this Total Price. It'll be a currency field. We'll give it a caption of total price. The difference between caption and heading is that the caption is the name that appears in the Stonefield Query dialogs, whereas heading is the default column heading for a particular report. By the default, they're the same, but they could be different. I could use an abbreviation for here, for example, and maybe even specify a two-column, two-line high heading. By default, I want dollar signs displayed, and I want commas every 3 places and 2 places after the decimal. Now, on the calc page, I have to tell Stonefield Query what the output expression or the formula that's used to calculate the value for this field. I'll just click on the expression builder to bring up the dialog where I can very easily choose the fields for that. So I want unit price times quantity. And I choose OK, and now here's my new calculated field. We can see by the icon in the list that it's not a true field, it's a little calculator. Other kinds of customization we can do are to define that certain fields contain enumerated values. We see this in accounting systems a lot, for example, where invoice status might have P for posted, I for invoiced, V for voided, things like that. In this case, we have a ship via field that is an integer field. It contains values like 1, 2, or 3, where 1 means FedEx, 2 is UPS, and so on. So the problem is if the user queries on this field, they're going to see a 1, 2, or a 3. So on the special page, we'll tell Stonefield Query that this field contains enumerated values, and we'll define a 1 as FedEx, a 2 as UPS, and a 3 as mail. So the user will never see a 1, 2, or 3 in the Stonefield query. They'll only see FedEx, UPS, or mail. In my products table, I have a category ID field that's a foreign key to the categories table. So if the user wants to show the category name and the product name, they have to grab the category name field from the categories table and the product name field from the products table. To make it easier on the user, we can make it look like the category name is actually in the products table. On the special page, I'll tell Stonefield Query that rather than displaying the values from this integer foreign key field, which are meaningless to the user anyway, we can display a field from related table. So we'll indicate that we want to display the category name from the categories table. So Stonefield Query will go and grab this category ID, look it up in the categories table, find the matching record, and then display the category name instead. And to make it more obvious to the user, we'll change the caption from category ID to category name. So you can continue with this kind of customization of the data dictionary, doing things like creating virtual tables, creating calculated fields, scripting your tables and fields, and so on. Those are all topics for another webinar. So I hope you enjoyed seeing how easy it is to set up Stonefield Query with your custom database, and good luck in working with Stonefield Query.
In today's lesson, we learned how to launch the configuration utility and create a new project, read in the structure of a database, add additional databases, specify connection information. We also learned how to customize the data dictionary. In here, we learned how to customize tables and fields, create calculated fields, and define enumerated values. Thank you for watching today's presentation with Doug Hennig.